When you first look at this tree, there's not much that stands out, is there? It's just another tree. Or is it? Look around. Other than the few sprinkled on this ridgetop, do you see any others? Because I certainly don't. What we have here is pitch pine, which is primarily identifiable by its needles. All other trees in the surrounding Middlesex Fells forest are deciduous and leafy, vastly different at best. Moreover, pitch pine is a fire plant, in that it thrives in environments where fire is a natural and constant occurrence. It has what are called serotinous or wax-covered cones. So what happens is that when a fire occurs, the intense heat melts the wax, allowing the seeds to become exposed and released by the time the fire has subsided, and the surrounding area that has now been cleared by the fire is both fertile from the ash and spacious enough for the seeds to germinate and grow. Pitch pine is also what is known as an early successional tree, which basically means that it is one of the first forms of vegetation to grow in a region, especially after a forest disturbance such as fire. So the question becomes, why is pitch pine only at the top of this ridge? Or rather, why does it not constitute the majority of this forest? The answers to our question may seem counterintuitive based on our assessment of this forest. If we take a look around inside the interior forest, we will notice that many of the larger trees have burn scars, indicating that a fire swept through the forest at some point. Perhaps even recurring fires. Furthermore, given the amount of small trees in the forest, we can tell that it is rather young. In fact, if you were to core these trees right now and count their rings, you would see that a good deal of these newer trees are somewhere around 30 years old, meaning the most recent of these fires occurred around that long ago as well. Interestingly enough, should you also happen to core the pitch pine, you would find them to be at least 2 decades older, aging the pine woods on the ridge at around 50 years old. Well, given what we know about pitch pine, being that it thrives in fire environments and works its magic quite well after disturbances, one would think that we would see a lot more pitch pine in the interior forest, and yet here we seem to have the opposite. Let's take a look at our friend pitch pine on the ridge again. Remember how I said pitch pine has serotinous waxy cones? Well, if we take a closer look at the cones on these particular pines, we'll notice that they in fact do not have any waxy substance coating them at all. These pitch pine are non-serotinous. So right off the bat, we get an understanding that this region isn't regularly visited by fires, even though the most recent of these fires seems to have engulfed much of the surrounding area. So great, not a fire region. And even with the blazes that may have passed through here several decades ago, this particular species of pitch pine wasn't even well equipped enough to handle fire in the first place. So even if it did exist in the interior forest, it wouldn't thrive. So how then does it exist on the ridgetops? Considering fire scars in the surrounding woods, we find none of them at the top of the ridge, most likely due to its less densely populated area and the fact that the rocks themselves acted as a sort of barrier between the burning forest below and the ridge. So fire wasn't able to lick the trees at the top, sure, which explains how the pitch pine is actually even older than the newest interior trees. But there is more at work here than meets the eye. The pines also have shorter root systems, which allow them to survive the rockier terrain of the ridge, where the hardwoods simply wouldn't have the necessarily leg room, so to speak, to lock themselves down into the soil. Additionally, pine is much more resilient to the elements of snow, rain, and wind than its hardwood counterparts, another bonus if you're living on the ridge. So great, all of these elements combined give us some decent explanations as to why the pitch pine is found only at the ridgetop. but we want to know how it got up there. Was it human intervention with planting seeds, or perhaps even animals or the wind, dispersing seeds onto an area that was hostile towards some species but not others? Sure, that seems viable enough a reason. But then we have the age of the surrounding woods versus the age of the pitch to consider. Let's take a step back from all of this now. Remove ourselves from the subject and re-examine the landscape around us. What do you see in this interior forest? Hardwoods, yes, but more importantly and specifically, we have oaks and beeches. Remember how I said pitch were the first trees to take up a space? Well, oaks are generally the last. They are what you would call late successional or climax species, whereas pitch pine is known as an early or initial successional species. What does this tell us? A whole lot, actually. Because the funny thing is that the forest you see here today is not the forest that's always been here. In fact, there weren't any trees here at all some 10,000 to 12,000 years ago. Instead, the entire northern portion of the United States was covered by what geologists call the Laurentide ice sheet, a thick sheet of ice about a mile deep that spanned across the continent and up towards the North Pole. To keep in mind is that this ice sheet reached as far south as modern-day Long Island, New York. And south of the ice sheet was an ice-free zone known as a refugium that was noticeably warmer and more hospitable to vegetation and wildlife. As the climate began to warm, the sheet melted and receded in turn. In time, the newly exposed land would become inhabited by forests, or rather by individual trees, because forests don't travel as a community, although we might be inclined to believe they do, given what we see in forests today. Moreover, the individual species definitely don't travel at the same time, or even within a few years of one another. Try more, several thousands of years. Why? Because of the climate that exists, and other natural phenomena such as forest fires or floods. But as one species of tree moved north with the increasing temperatures, it soon began to change the landscape. And not only the landscape, but also the animal species that existed in that previous ecosystem. The old inhabitants either increased or decreased in population, depending on how well they were akin to their new habitat. And as a result, this change in population sizes and even species type changed the food chain, which once again changed the ecosystem in a sort of cyclical nature. By the time the next tree arrived to either overtake its predecessor or to mingle with it, the whole cycle repeated itself, forever changing the landscape once again. Applying this concept of singular species travel and the lag between species of trees, we get a very different sense of what the fells most likely looked like thousands of years ago. Imagine, instead of all these hardwoods, a forest of pitch pines for as far as the eye can see. This forest dates to about 10,000 to 11,000 years ago. Maybe 1,000 years later came the hemlock and oak. Then around 8,000 years ago came beech, with hickory following 2,000 years later, and chestnut being our most recent arrival some 2,000 years ago. With this knowledge of traveling trees and lag, and the concept of succession, from early successional trees like pitch pine that are eventually replaced due to competition with mid-successional trees, and finally the climax species, we can understand that the pitch pine on the ridge is actually a descendant of its 10,000-year-old self, where once it was the entirety of the forest. Now, because of competition with larger trees and more densely populated forests, it can only exist where its competition cannot. The best analogy for the succession of forests is the rise and fall of empires, where in this case pitch pine is the small remnants of a once vast and powerful empire. Understanding this rise and fall of species and succession can help us predict what species of trees will be the first to move northward with the oncoming increase in temperature. And with the changing of landscapes once again, we can then in turn tell which species are at risk for over and underpopulation, or even extinction. In the same right, by understanding the inherent lag of succession, we can also go back further in time to recreate past ecosystems and guess as to which animal species existed in these vastly different forests in these vastly different times. So at the end of the day, the pitch pine is a flag of ancient histories, ones that it has been extensively involved in shaping and map out both past and future, while bringing greater understanding to our present.